Thank you very much, Priyakshi and EV Reporter, for inviting us and giving us the opportunity to talk about uh, our perspective around the current lithium-ion battery recycling landscape, leading players, and some of the other updates. Just a second. Gaurav has already talked most of it, but I'll try to add some value to the audience. We have people in large number attending this webinar. And before I begin, a few things are very hard to believe. For example, if I remember when I started working around electrification, that time there was no presence of or even no talks around recycling. And I personally never expected that whatever level we have achieved so far would be achieved within, let's say, 5 to 6 years of time. So I think the progress has been commendable. In today's presentation, let me talk about my perspectives around need for recycling industry, especially in India, overview of current policy landscape, LiB recycling volume potential and capacity, then the key players in the recycling industry in India, and the way forward. Let me briefly talk about the need for recycling in India. There are different risks. For example, geopolitical supply risk, hazard and sustainability, and the price discovery. If I talk about geopolitical supply risk, then there is no developed lithium mining and processing activity in India. It's completely reliance on the imports. China has biggest share in processing of lithium and a strong control over sourcing of critical minerals in LiB. So that becomes a very big geopolitical risk. Hazards and sustainability can be like 55% lower GHG emissions on utilizing recycled lithium compared to virgin LiH from mines. And same is the price discovery. So resale risk pertains around EVs, mainly due to the battery. So recycling improves resale value of batteries and reduce the cost of input material. So recycling can help in solving the challenges. Basically, it can be a hedge against geopolitical risks. So to supply chain improve sustainability. It also allows reduced pricing for batteries and eventually EVs. Moving on, overview of current policy landscape. If I remember, the Battery Management and Handling Rule 2001 has not even included, which was again, I think, updated in 2010, but it was not including the lithium-ion batteries. And there was a amendment of Battery Management and Handling Rules in 2022, which was further amended in 2023. And now lithium LIBs are part of these rules, and we have comprehensive policy, which further needs some of the improvements, but at least we have now a very good base. In terms of the key points of this policy, transactable extended producer responsibility, the EPR certificates or the EPR responsibilities are one of the very important part of this policy, which will bring a lot of changes the way recycling is done, or at least it is going to give a lot of responsibility to different stakeholders on in the recycling industry. So I think this is known to everyone that there are different stakeholders in the recycling, and each stakeholder has different responsibility, starting from waste generation stage, wherein you have producers and the consumers. Producers has the responsibility to introducing the batteries into the market, collecting, recycling, and refurbishment. And consumers definitely have to be responsible for responsible disposal of battery waste. Then you have waste collection stage, in which we have Public Waste Management Authority, collection, segregation, and treatment entities. And eventually, we have recycling companies, which you can say the refurbisher and the recyclers. One of the very important part of the policy, which is giving further role or further responsibility to the recyclers, is that, they have the recovery targets for battery materials together with, obviously, they have to follow CPCB standards. They have to manage hazardous waste, manage other solid state waste as well. But the recovery targets are very important for electric vehicle related If you look at in 2024, 2025, 70%, then 80% in 2025 and 6, and after that 90% recovery targets has been has been part of the policy. Also, in terms of EPR targets, which has been starting from 26 to 27 until 2032, if you look at every year, at the gap of 4 years, the 70% of the quantity of batteries placed in the market has to be are like mandatory waste, and battery collection target 100% of the refurbishment. So, and these targets are very well defined for two-wheeler as well as the all kind of vehicle segments in India. It is very similar to different vehicle segments, other than there are some changes for the three-wheeler sector. Moving on to the LiB recycling volume potential and the capacity part, which I would like to talk. In terms of recycling volume potential, if you look at the left-hand side of the chart, which has starting from 2022 to 26 and 2030, talks about the India battery demand. So India battery demand is approximately 232 gigawatt hour in 2030, which includes stationary as well as the electric mobility. Electric mobility itself goes beyond 100 kilowatt. And Gaurav was talking about the number of gigafactories we require to have such facilities. So the demand is very high, and it is definitely going to be the mix of import as well as the domestic manufacturing. There are domestic manufacturers as part of the PLI scheme. We have 3. There are traditional, non-traditional manufacturers, as well as the startup companies who have announced their capacities, including the traditional battery manufacturers like Amara Raja and Exide. So we can see some traction from there also. Even if it becomes all reality, if you calculate the announcements, then also 50% at least is going to be imported. That is what we estimate. Now, if you look at the lithium demand in kilotons for LIBs, by 2030, it's going to be only lithium I'm talking about is going to be around 16.1 kiloton. So even if India meets half of the demand locally, it leads to demand of around 8,000 ton lithium in 2030. And if the announcements which we have or the discoveries which we have around lithium extraction becomes the reality, then also it's going to take almost a decade. And recycling of lithium from imported batteries would be very, very important for meeting the local demand, which means there is a huge opportunity for the recycling, and recycling can add a lot of value as well. So let's take a look. In the previous presentation, we were talking about who can be the buyers. So the buyers of these the materials, the extracted materials can be CAM material, cathode active materials can be CAM manufacturers. Then even once you have the cell manufacturing, I was talking about 230 plus gigawatt hour of total demand, mostly coming from e-mobility. Then once it is out from the electric vehicle, it can be reused. So approximately 30 to 60% can be repurposed for reuse in stationary and grid applications. Then you have 2 options. Some of them are definitely going to go into the landfill, but mainly they can be collected and dismantled, and material extraction can happen, and eventually it can be fed into the cell manufacturing process. The CAM manufacturers can utilize them, and this is how you can close the loop. So let me talk about the lithium LIB recycling and reuse volume potential estimates, and I'll talk only about 2030 numbers. So reuse potential is around 18 gigawatt hour, recycling potential is around 22 gigawatt hour. There will be batteries coming out of two-wheeler and three-wheeler segment, and they will be mostly directly going for the recycling because of the nature of the batteries. But the batteries which are going to come out from the four-wheelers as well as the bus applications, buses segment, they can be, majority of them, they can be reused in the applications like stationary, mainly into the stationary application. So for 2022 to 2030, if we look at the cumulative numbers, 49 gigawatt hour can be reused in the EV segment. 59 gigawatt hour recycling opportunity is going to be there in the electric vehicle segment. In the stationary application as well as consumer electronics, reused batteries are going to be limited, but the the recycling opportunity is around 53 gigawatt hour and 15 gigawatt hour respectively from the stationary applications as well as the consumer electronics. Moving on, I'll briefly touch upon the recycling technology and capacity. So globally also, in India also, there are different methods of recycling, and these methods are also evolving because of the evolution in the battery chemistry side. So we have direct recycling, which is happening in India also, and then you have mechanical processing, which is like then pyrometallurgy and hydrometallurgy. These are the kind of recycling methods which globally as well as in India are being used. Many of the methods are also like a kind of mix of or the combination of these methods. For example, in direct recycling is mostly suitable for LFP chemistries, which are available in pouch and prismatic form factor. If I talk about pyrometallurgy generally works for majority of chemistries, but lower applicability for the LFP chemistry. And what I have seen is like the method is also agnostic to type of chemistry, but requires large volume to justify the cost related to smelting. Then for the hydrometallurgy, it works for leaching, followed by selecting precipitation and extraction with solvents. And most higher efficiency extraction efficiency would involve a combination of methods, not only one type of method. Moving on, let me briefly talk about the global recycling capacity. It is well known to all of us that China again dominates in the recycling capacity as well. So globally, we have around 400,000 to 450,000 tons per year by end of 2022, based on declared capacities of different recycling companies. And China holds approximately 50 to 60% share of recycling capacity. If I talk about India, it's relatively much more small, and it goes to around 5%, which has increased in the last few years as I started, I was talking in the beginning that now it is picking up. Earlier, it was much lesser. Let me briefly talk about global recycling players. So here we have listed 15 recycling companies which are present globally. You can see the location here, and I'll only talk about the kind of methodology or the kind of technology which they are using. And so one point I want to mention over here is that many of them are like combo, pyro and hydro, and some of them are pyro purely, but yes, the trend is like the combination of these technologies. Moving on, the lithium-ion recycling capacity in India market, there are good companies, and some of them I have seen growing personally also very fast in last few years. I'll talk about few companies. Exigo has recycling capacity of 7,200 ton per annum. Then Atero has 4,000 TPA. Batex is also one of the companies which is very aggressive in this, around 5,000 ton per annum. They have the capacity. Then we have Rubamin, 10,000 TPA. Then we have companies like Lyco Materials, and then some other companies like Tata Chemicals, Sungil, and LI Circle. So I'll briefly talk about some of the activities which Indian recycling companies are doing. So here, let me first talk about the Exigo Recycling. So they have a facility, a large plant in Panipat, the state of Haryana in India. The capacity is 7,200 dedicated to LiB, using the mechanical as well as the hydrometallurgy technology. And they have a dedicated a small R&D center which works on development of the equipment as well as the new methods of recycling. Their preference for NMC chemistry over LFP. They have tie-up Wizlog for reverse logistics. They serve clients like Panasonic, Samsung, as per the data available. And they also plan to extend e-waste processing capacity up to 200,000 ton per annum. Then I talk about the Batex, which has 4,000 to 5,000 tons per year capacity for lithium-ion batteries. mainly using the mechanical technology, which means producing the black mass and selling it to the downstream suppliers who can do the metal extraction. Then we have Rubamin with 10,000 commission in Q2 of 2024 using hydrometallurgy. They have 30,000 tons per annum capacity, which is again expanding. Expansion is planned in the phased manner with initial operations starting 2024. Expertise in hydrometallurgy with processing of catalytic content. These are the companies like Exigo, Atero, Batex, Rubamin. They have expansion plans, very rapid expansion plans. In the recent past also, they have expanded, and now in the future also, they have a very rapid expansion plan, approximately 2 to 4 times increase in capacity. Then we have other set of companies like Lyco Materials, Recycle Caro, and others who are producing the black mass processing, but they are also expanding into extraction processes. And if industry develops faster, or at least with the current pace also, within few years, some of these companies are also going to upgrade and start doing the material extraction, not only the black mass processing. So Lyco is a company which I think Gaurav has already talked in, based out of Mumbai, 3,000 tons per year capacity, mechanical technology. Current focus is on separation of current collectors, plastics, shredding to create black mass, expansion to mineral extraction by hydrometallurgy with setup of 10,000 tons per annum capacity. There are many more. For example, let me talk about Sangil High Tech India. They are available. They are based out of Anandpur in Andhra Pradesh. They have 10,000 for total capacity of e-waste hydrometallurgy processes, or the technology they follow. It's a subsidiary of Korean company, and one of the speakers I think will talk about this company in detail going forward. Then we have companies like Mini Mines. They have also capacities 3,000 tons per year, mechanical and hydrometallurgy, and expanding very fast. And they have patented hybrid hydrometallurgy technology as well. So this was all about why recycling is needed, what has been the past growth in India, how the future is look like, what is the competitive landscape, and how the companies in India for the material extraction as well as the black mass producing are placed, and how the future looks like for the lithium recycling in India. The way forward, let me briefly talk that, yes, as I mentioned, that there are so many challenges around recycling. For example, the battery technologies are evolving. There is no fixed technology that this is going to be the future, and it's very, very difficult for recycling company to guess and make a strategy that on which technology they are going to tap. So it's going to be a continuous investment and innovation for them as well. Battery material prices are very high, and the cost of recycling is very high. So sometimes it becomes very difficult to recycle and even generate profit from the recycled material. Then we have the battery pack. As I mentioned, the structure complicates the recycling. Then you have battery collection and transportation. LiBs are highly reactive, and safe transportation is a very, very big challenge. Yes, there are many challenges, but at the same time, it's a new industry emerging. It's a new field. So there is a lot of opportunity also. So for example, in terms of newer opportunities, the Indian recyclers, on account of expected growth of spent batteries, new business models can be explored. 2-3 years back, I thought that it's going to be a oligopoly market structure, but now you see many players operating in different capacity and also planning for upgrading themselves. So it's coming out to be a fragmented market. So in future, there is a scope for consolidation. Partnerships in recycling between incumbents and global leaders. So if you look at the automotive OEMs in India, I think definitely all of them are going to be with electric vehicles in India. They have very, very limited recycling capability by themselves. So they are going to depend on technology alliances, joint ventures, etc. So the recycling company, which evolves and upgrades and becomes a large player, definitely going to be finding a way to be part of a large OEM also, because all of them are also looking for such partners. Strategic collaborations, as I mentioned, with the OEMs and the trading houses, battery manufacturers, there is a high possibility of a strategic collaboration. So that's all I wanted to talk. I hope it was useful. Over to you, Priyakshi.
Thank you, Pritesh. Definitely, it was useful and very insightful. Gave us an overall overview of the industry and especially who the players are. So it was very useful to have that list kind of a thing where it sort of summarizes the overall ecosystem for us. So thank you for that.